Hi, my name is John Parks,
And I'm Jed Benedetti.
I'm Jonathan Bonner.
and we did our presentation on rubber. Now we're going to talk about where natural rubber and synthetic rubber comes from. Asia is the main source of natural rubber. The three largest producing countries are Thailand, Indonesia, and Malaysia. Together they account for 72% of all natural rubber production. The second type of rubber is synthetic rubber. The first synthesis of rubber was carried out in 1909 in Germany by F. Hoffman. It was first used in the U.S. market in 1931 by DuPont de Nemours under the brand neoprene. The first development of synthetic rubber increased during the Second World War. It takes several quite distinct steps to make a product out of natural rubber. First, you have to gather the latex from the rubber trees using a traditional process called rubber tapping. That involves making a wide, V-shaped cut in the tree bark. As the latex drips out, it is collected into a cup. The latex from many trees is filtered, washed, and reacted with acid to make the particles of the rubber coagulate, to stick together. The rubber made this way is then pressed into slabs or sheets, and then dried and ready for the next stage of production. By itself, unprocessed rubber is not that useful. Next, we're going to talk about how synthetic rubber is made. Synthetic rubber has its origin in two gases, butadiene, a byproduct of petroleum refining, and styrene, captured either in the coking process or as a petroleum refining byproduct. When the two are mixed together in the presence of soap suds in a reactor, liquid latex results. The dry rubber in this milky liquid is then coagulated into crumbs, washed, dried, and then baled and is ready for shipment. Now we're going to talk about what the material looks like. On the right, you can see synthetic rubber, after the process of styrene and butadiene being mixed together and the crumbles of rubber being dried and baled together. And on the left, you can see the natural rubber. As seen in the picture, you can see the rubber tapping, where the liquid latex drips down into the bowl.
Now we will look at what rubber is good for and what it's bad for. On the pros side, it's flexible, so it can be used for things like hoses. It's also relatively impermeable to gases, which make it ideal for insulation and medicinal tubing seals. It resists water and other fluids, so it can be used for rainwear, and it also resists electricity, which make it perfect for insulative gloves or shoes. Now we will look at the cons of rubber. It can cause an allergic reaction due to its containing latex, and natural rubber can also be degraded using bacteria. It also has limited strength, meaning that if it's stressed too much, it will break, and it has a small, limited working temperature because it melts at 180 degrees Celsius and it hardens due to crystallization at 5 degrees Celsius. We will now look at a list of the primary characteristics of rubber. Density is fairly self-explanatory and a concept we're all familiar with. It's the amount of mass per unit volume. The embodied energy is the total amount of energy per unit mass it takes to produce the substance. Now you'll notice there's two different numbers. The number on the left, 67.5, is for natural rubber, and 110 is for synthetic rubber. It takes a little bit more to make synthetic. The price in dollars per kilogram is 118, and tensile strength, which is the maximum force a material can withstand without fracturing when stretched. Then we have the water usage in liters per kilogram. That's how much water it takes to make a unit mass of the material. And finally, we have Young's modulus, which is a measure of the stiffness of the material.
Next, we will be discussing rubber's response to multiple manufacturing processes. The first two processes in this discussion will be molding and forming.